Welcome to this demonstration. Today, I'll be showing you how to get a website up and running on Amazon Web Services with just a few steps. We'll be using the Cloud Development Kit, or CDK, to set up everything using code. We'll be working with a simple website created using Next.js, one of the most popular frameworks for building web applications. Our goal is to deploy this site to AWS, making it accessible to users all around the world. We'll also ensure that our website is secure, using best practices to protect it. Let's talk about the AWS resources we'll be using to build and host our custom website. AWS provides a suite of powerful tools that make it easy to create a highly available, secure, and scalable website. In this project, we'll be leveraging 4 key services: S3, CloudFront, Route 53, and Certificates Manager, all deployed and managed using CloudFormation. First up, we have Amazon S3. S3 is a highly durable and scalable object storage service. We'll use it for hosting our website static assets like HTML, CSS, JavaScript, and images. S3 ensures that our content is stored securely and can be accessed by our CDN. Next, we'll use Amazon CloudFront for our content delivery network. CloudFront distributes our content globally to reduce latency and ensure that our website loads quickly. We'll use Amazon Route 53 to manage DNS records. As you know, security is a top priority, so we'll secure our website with AWS Certificate Manager. This allows us to easily provision, manage, and deploy SSL or TLS certificates for our domain. This ensures that data transferred between our users and our website is encrypted and secure. All these resources are deployed and managed using AWS CloudFormation. CloudFormation allows us to define our infrastructure as code, making it easy to automate and manage. By combining these AWS services, we can build a robust, secure, and scalable website that's easy to manage and delivers a great user experience. Now, let's dive into setting up these resources in our project. First, let's initialize our project. I'll start by running yarn init to quickly set up a package.json file. Next, we'll add a few dependencies to our project. This includes 2 CDK dependencies, constructs, and node type definitions. With the setup complete, I'll open the project in WebStorm to begin writing our infrastructure code. We'll create a couple of essential configuration files. I'll use the terminal in WebStorm to do this. First, I'll create 2 files using the Linux touch command for both the tsconfig and cdk.json files. I'll paste some existing configurations into each of these files. I won't go into detail here, as these are standard setup files. But let's briefly look at one key part. There's an important line that defines the app command, which is found on line 2 of the CDK.json file. This command tells the CDK to use TypeScript to run our main TS file, which is where we'll be writing our infrastructure code. Now, I'll do the same for the tsconfig file, which contains standard TypeScript configuration settings. These configurations ensure that our TypeScript code compiles correctly and is compatible with the CDK. Now that we have our basic project set up, let's create our Next.js demo application. First, I'll create a new folder in the root directory called Apps to keep things organized. Next, I'll open Firefox and head over to the Next.js website to grab the command for creating a new Next Starter project. Back in the WebStorm terminal, I'll change directories into the Apps folder and run the command to create our next project. The Next.js command line tool will ask several setup questions. I'll name the project Website and accept all the default settings. While the next project is being installed, I'll go ahead and create a new directory and file for our CDK code. In WebStorm, I'll open the New File dialog, create the main.ts file. This will automatically create the source folder and add the main.ts file to it. Next, I'll open the source folder in the Project Explorer, right-click, and create a new directory called Stacks. Inside the Stacks directory, I'll add a new file named Website Stack. This is where we'll define the infrastructure for our Next.js application. By now, the Next.js project should be done installing. I'll open a new terminal session, change into the website directory, and run npm rundev to start the development server. We'll verify that our site is loading correctly by visiting localhost in the browser. Everything looks good, so I'll stop the server and make some configuration changes. I'll open the next configuration file and add a few overrides to customize our setup. Finally, I'll build the project using the build command in the terminal. This will generate the production-ready files for our site. Now that we have a demo website to publish, we're ready to build our cloud resources. In the main.ts file, we start by creating a new app construct. This is the entry point into our CDK application. For now, there's not a lot we can do in this file, so we'll immediately switch over to the website stack file. This is where we'll build out our infrastructure. When working with the CDK, there's a common pattern you'll follow when building your infrastructure. You'll typically extend the stack-based class for your own classes. In addition, you'll define custom interfaces for your props. These interfaces commonly extend the stack props interface. Within the website stack file, we'll create a new JavaScript class which extends the stack-based class. Next, we'll define the constructor method and the props interface. The method signature for our constructor method includes the scope, ID, and our custom props. It's common to name the interface after the stack name and append props to the end. Here, we'll eventually define custom properties that are required by our stack. As I mentioned previously, our custom props will extend stack props. Once we call the super method and pass in our constructor arguments, we're ready to initialize our stack in the main.ts file. Let's do that now. We'll new up an instance of our website stack class and pass in the app as the scope. Provide an ID and the props. The ID is important here because this will define the name of the stack when calling the CDK deploy command. We'll give our stack the ID of demo stack. Because we extended the stack class, we need to provide an env or environment property which specifies the account ID and region. Next, I'll show you how to find your account ID, and we'll use the US East 1 region. Back in the browser, I've logged into my AWS portal. I'll sign into the AWS console, and in the upper right corner, I'll copy the account ID, paste it into the code as a prop. At this point, we've created a simple stack and initialized it in the main.ts file. The stack doesn't do much yet. Let's start adding our resources. We'll create a handful of constructs. To get started, we'll create a reference to our Route 53 hosted zone. This is an example of how you reference an existing resource in your code. In this case, we're not creating the hosted zone because it already exists. Next, we'll create an SSL certificate using the Certificates Manager. We'll create an S3 bucket to store our website files. I'll show you how to automatically deploy those files to the S3 bucket during a CDK deployment. We'll restrict direct access to our S3 bucket. We'll configure the bucket policy so that only our CloudFront distribution can access the contents using the origin access identity. No one needs to be accessing the website directly through S3. Finally, we'll create the CloudFront distribution and configure the Route 53 Apex record and a CNAME record. We're about to create our first prop for the website stack. Props are essentially configuration parameters that we can pass down into our stacks. Think of them as a way to customize how a stack behaves without changing the underlying code. For example, let's say we want to deploy our application to different AWS environments, like development and production. We don't want to write separate code for each environment. Instead, we can use props to define environment-specific settings. By passing these props into our stack, we can reuse the same code across multiple environments, making our project more flexible and easier to maintain. As you create your stacks, you'll pass in these props, which might include things like resource names, environment-specific configuration, or even security settings. This way, we're not hard-coding values directly into our infrastructure, but rather making it adaptable to whatever environment we're deploying to. Back in the code, I'll be adding an environment-specific prop called Hosted Zone ID. As soon as we add this custom prop to the website stack props interface, we'll need to update the main.ts file to include this new property. Back over in the AWS console, we'll go to the hosted zone in Route 53 to find the hosted zone ID. For the hosted zone, click into the hosted zone details to find the ID. Also, take note that the hosted zone name can be found here. We'll be creating a second property on our interface called zone name. At this point, we've created two new properties on our interface and copied the hosted zone details over to our custom prop found in the main.ts file. It's time to obtain a reference to the hosted zone using the hosted zone construct. I've chosen to use the FromHostedZone attributes method to create this reference. We will pass in the hosted zone, ID, and zone name as properties of this construct. We'll assign the result of this method to a constant called hosted zone. We'll use this later in the code. Next, we'll create the SSL certificate by instantiating a new certificate construct. We'll pass in a few properties to customize the certificate, including the certificate name, domain name, validation method, and the subject alternative names. I will hard-code the certificate name to website certificate. This is fine since we're creating a single certificate in the stack. The domain name can be assigned the value we provided in props for the zone name. This might be different in your case, but works for this scenario. In order to validate the certificate, we're setting the validation method to use DNS validation. Finally, we configure the subject alternative names, or SANs, to include both the root domain name and an optional wildcard. At this point, we've got enough details to create our certificate. I've assigned the results of the certificate construct to a constant named certificate. We'll use this with our CloudFront distribution. Let's move on to S3. Next, we'll use the bucket construct to configure a new S3 bucket. Again, this is where we'll store the website files. Many examples you find on the internet will show you how to enable the S3 bucket for website hosting. We won't be doing that. Instead, users will access the website through the CloudFront distribution, not through S3. To accomplish this, we block public access on the bucket and configure origin access identity. This is a technique that only allows our CloudFront distribution to access the bucket contents. I've configured the bucket to automatically be destroyed and have all the contents deleted when the stack is destroyed. You'll need to decide if you want to preserve the bucket or its contents. Now, we'll configure the bucket deployment. This is a helpful feature of the CDK that allows you to deploy assets to S3 during a deploy. In our case, we've already built the Next.js application by running the npm run build command. We'll deploy the website as part of our deployment. Using the bucket deployment construct, we can specify the source and destination properties. The sources property will be an array containing an asset pointing to the Next.js application. We have our third prop to add to our interface. Back in the interface, we'll add a new property called source. Through this property, we will provide the path to the output folder created by the next build command. We're including this as a configurable property because this will vary based on the project. Next, we'll configure the origin access identity and grant read permissions to this identity. CloudFront will use this to retrieve the contents of the S3 bucket. Now, it's time to create the distribution. This is the most complex construct that we'll be configuring in this example. At a high level, we'll configure the default behavior, customize the error responses, assign the domain names, and a few other properties. Let's get started. For the default behavior, we'll set the origin of the distribution to point to the S3 bucket. Furthermore, we assign the origin access identity here. We'll allow all HTTP methods and configure the viewer protocol policy to redirect to HTTPS. As we're deploying a Next.js application, there's an important configuration step we need to take care of in CloudFront, handling 404 error responses. This means that even when a user navigates to non-existent routes, the application should still handle the request gracefully, typically by serving a custom error page or redirecting to a specific route. We'll configure CloudFront to redirect all 404 errors back to our application. We're only configuring CloudFront to send 404 errors back to the application. We could configure others as well. We will return a status code of 200 and set the time to live for 30 days. Here, we're defining the domain names property, which includes the primary domain for our site, as well as the www subdomain. Next, we attach the SSL certificate we created earlier, specify HTTP version 2, and assign the default root object. We're almost done. We'll finish up by creating the DNS records. We'll create an Apex record and set the target to our CloudFront distribution. We define a CloudFront target for this. Configure the zone, which is our hosted zone we defined earlier, and the record name. Next, we configure the CNAME record, we specify the zone record, name for the www subdomain, and configure the domain name to point to the CloudFront distribution's domain name. There's one last step that we need to do. Earlier, while we were configuring the S3 bucket deployment, we created a custom prop named source. We need to add this prop to the main.ts file. We'll add the source property now. We'll use nodes path.join method to create the path for us. We pass in 3 arguments into this method, each representing a folder within the path to our website files. You can think about it like this. Starting from the root folder, I want to upload the files in the app/website/out directory. At this point, we're all set and ready to synthesize, then deploy the stack. Let's do that now. In the terminal, while in the root directory, I'll run the yarn CDK ls command. This will list my stacks. This is similar to the Linux ls command, which lists the files in the current directory. The CDK will list your stacks when you run the list command. The project is synthesized, and then all stacks are listed. In our case, we have our one stack listed in the output. Now that we know the stack name, we're ready to grab a set of short-lived AWS access keys, run a diff, and deploy. I'll copy the temporary access keys for my temporary user. I'm okay with showing these to you because by the time this video is published, I will have deleted the user and all of the resources. And now I'll run the diff command. Type yarn CDK diff, followed by the stack name, and press enter. This command will output the differences between the stack itself and your AWS environment. Since we're running this for the first time, we don't have any existing CloudFormation template to compare it to. Review the changes being presented in the diff. When you're ready, type the command yarn CDK deploy followed by the stack name to publish the changes. When prompted, type Y and press enter to confirm these changes. This will deploy your resources into the cloud. If you like, you can head over to the AWS CloudFormation console to watch the progress of your stack deployment. Now that our stack deployment is complete, we can head over to Firefox and test the website. And there we have it. We've successfully built the infrastructure as code that will deploy a fully functional website to AWS. From setting up our S3 bucket and configuring CloudFront for global content delivery to securing our site with SSL certificates and routing traffic through custom domain names, we've covered all the key components needed to launch a secure, scalable website. By using the AWS CDK, we've not only automated the deployment process, but also made our infrastructure easy to replicate, manage, and adapt to different environments like development and production. Now that we have the website up and running, let's show you how to delete these resources. You can run the yarn CDK destroy command to delete the stack. This will delete everything we've created here. And just like that, all of these resources have been deleted. The only exception is that a CNAME record still exists in your Route 53 hosted zone. This was created by the AWS Certificate Manager for validating your domain name. You'll need to delete that record manually. Otherwise, the resources should be all cleaned up. With this setup, you're well on your way to hosting your own websites on AWS, leveraging the power of infrastructure as code to ensure consistency, security, and scalability. Thanks for following along, and I hope you found this helpful. Stay tuned for more tutorials on building with AWS.